Do you know how to calculate the surrounding rock pressure? Speaking of the calculation of forces, you might think it is difficult. But don't worry, we can use the association method. We can imagine the tunnel as a rectangular carton. If it is sunk in water, the water body directly above the carton, both sides of the carton will naturally deform outward. At this point, the reaction force of water body will constrain its deformation and produce horizontal resistance. This is a simplified force model of the tunnel, showing the principle of surrounding rock pressure acting on the supporting structure. Now, it seems that the calculation of surrounding rock pressure becomes simple. In actual engineering calculation, the surrounding rock pressure is relatively complex. Here we consider the primary factors only and skip the secondary factors. Therefore, we can simply calculate the vertical uniform pressure Q and the horizontal uniform pressure E. The treatment of regarding the same load being borne on each point can also meet the requirement for engineering accuracy. In the process of tunnel excavation, the tunnel will pass through sections with different burial depths and different surrounding rock grades. Certainly, the surrounding rock pressure is always changing. In the calculation of the surrounding rock pressure, the surrounding rock grade and burial depth must be considered. In general, most of the urban metro tunnels are built in soft soil and can be reached by taking 2 floors of escalators, while most railway tunnels are buried deep in mountains and mostly in hard rock. In terms of surrounding rock grade, excavation of a tunnel with a higher grade of surrounding rock results in less collapse volume, lower possibility of collapse and smaller pressure of surrounding rock. In terms of the burial depth of the tunnel, the collapse of rock and earth mass will inevitably lead to slide of surrounding rocks around. If the burial depth is small, the sliding surface of the surrounding rock will reach the ground. While, if the burial depth is large, the sliding of surrounding rock is only within a certain range underground, without disturbing the ground and forming the arch. Therefore, the calculation method of surrounding rock pressure varies with burial depths. So how do we identify if a tunnel is deep or shallowly buried? Based on the arching effect and a lot of statistical data, a stable natural arch will be formed only when the burial depth h is at least 2 to 2.5 times greater than the height ha of a collapsed arch. This critical depth is called HP. That is, we call it a deep buried tunnel when the burial depth h is greater than HP, an ultra-shallow buried tunnel when the burial depth h is less than HA, and a shallow buried tunnel when the burial depth h is greater than HA but less than. Therefore, when calculating the surrounding rock pressure, we must abide by design specifications, make a clear distinction between deep and shallowly buried tunnels. Sometimes a small design error will cause major construction safety problems. Let's learn the calculation of the surrounding rock pressure of a deep buried tunnel first. Due to the arching effect, the rock and earth mass on the upper part of the collapsed mass will form a natural arch. The natural arch transfers the vertical forces to both sides. The surrounding rock pressure is only the gravity of the collapsed mass, independent of the gravity of the stable rock mass behind the natural arch. Based on the method in the design code, the height of collapsed arch is where S is the grade of surrounding rock. The vertical uniform pressure is where gamma is the unit weight of the soil. The horizontal uniform pressure E can be found in the following table. For example, for grade 4 surrounding rock, let's take a look at the calculation of the surrounding rock pressure of the ultra-shallow buried tunnel. As the burial depth of the tunnel is not large enough, the sliding surface extends to the surface, and the natural arch cannot be formed. Surrounding rock pressure and support structure reaction are a pair of interaction forces. Taking the sliding soil as the object of study, then the dead weight of sliding rock mass equals frictional resistance of sliding surface plus pressure of surrounding rock. If we further ignore the small frictional resistance of the sliding surface, Then the deadweight of sliding rock mass equals pressure of surrounding rock. Then we can calculate the pressure of surrounding rock. The vertical pressure of the surrounding rock of an ultra-shallow buried tunnel is, where h is the buried depth of the tunnel. The horizontal pressure of surrounding rock is, where ht is the clear height of the gallery and 5 is the calculated friction angle. Let's thoroughly comprehend the calculation of surrounding rock grade and surrounding rock pressure with an example. It is assumed that a tunnel of a single-track high-speed railway is 570 m long in total. After investigation, it is divided into 5 sections from entrance to exit. The grades and parameters of surrounding rocks are determined as follows. After this lesson, we know that the surrounding rock pressure is determined by the grade of the surrounding rock and the burial depth of the tunnel. Only by understanding the internal relationship between them can we master the calculation of surrounding rock pressure skillfully, adopt the supporting methods scientifically and reasonably, and ensure the safe construction of the tunnel. As a tunnel engineer in the future, in the face of complex and changeable surrounding rock conditions, you should respect the laws of natural change, dedicate to your posts and become an application-oriented talent in the new era of building a tunnel when blocked by a mountain and building a bridge when blocked by a river, with a rigorous craftsmanship spirit and a scientific attitude of seeking truth from facts. Calculate the surrounding rock pressure at point C of the shallow buried section of grade V surrounding rock based on what you learned. Share your problem-solving process in the discussion area.